Hello students, this is Anjana from Computer Science Department. In this class, we are going to discuss about message authentication requirements and the message authentication functions. So now let's get into our topic. Here, now let us see what are the message authentication requirements in the context of communications across a network. When we are in the network, the following are the attacks that we are going to identify. Now let us see what are the types of attacks that we are going to identify when we are in network. Okay. See, first one, disclosure. See, the disclosure means we are the release of the message contents to any person or a process not posting the appropriate cryptographic key. So without not providing any appropriate cryptographic key, if the from the particular sender it is sending some message without irrelevantly, we can say that particular concept as a disclosure. Okay, the disclosure is a release of contents to any whenever you are sending the data. What is the mean of a traffic? In the general term, the traffic means if in a congested area, if somebody is waiting, so what we say, we are waiting, we have to wait because of a low space. Because of the low space, we have to wait until the traffic has to get clear. So why the concept traffic will happen means, because only because of the congested place and multiple users. Okay, suppose multiple users are sending the data at that time, traffic may generate. So at that time, the system has get an ambiguity that which sender has to which sender's data has to send first. So at that particular time, the traffic analysis should be done such that the discovery of the pattern of traffic between the parties. First of all, you have to identify whether there is any traffic between two parties in a connection oriented application, and next the frequency and duration of the connection could be determined. So whether if there is any frequency between the connections, then it should be determined in either a connection oriented or connectionless environment. Whether it is a connection oriented environment or it is a connectionless, that is a wired environment or wireless environment. So the number and length of the messages between the parties could be determined based upon the number and based upon the length. The number of the parties could be determined. Then masquerade. So what is the concept called masquerade? So the insertion of the messages into the network from the fraudulent source, such that suppose some fraud persons has entered into our source, and instead of sending suppose if you are sending the message like hi, hello, how are you. Suppose a fraud third party person has came to your source, and they had entered some misfrequent uneven message in your message, just like after hi stupid, just like that they have entered a message like irrelevant message like that. Then it may cause damage to the particular source person, that uh, that by an opponent that are purported to come from an authorized entity, such that we have already included the fraudulent acknowledgements of the message receipt or non-receipt by someone other than message recipient. So from that we what from that how we can retrieve from that, just like we can send the fraudulent acknowledgement to the recipient, such that the message was sent by some fraud third party person, that it was not sent by the sender. Okay. And next one, content modification. See, whatever the entire content in our data, that entire content may be also modified. Suppose the changes of to the content moment of the messages, including the insertion, whatever the data he wants to insert, he will insert, or some important data he should delete, or we are going to transfer the data from one post. Suppose if it is in one language, it is transferred to the another language, or it may be modified from one form to the another form. So all these are the collection of the modifications such that which may cause the entire damage to the sender. So what is the content modification? It changes the contents of the message, including the insertion, deletion, transposition, and modification. So next one, what is a sequence modification? Any modification to the sequence messages between the parties, including insertion, deletion, and reordering. So if you are, suppose if you are having the lengthy message, that lengthy message is divided into some subsequent messages, so that the messages, if you are sending those messages in a sequence, but if you are modifying that sequence also, it may cause ambiguity for the uh, receiver who is going to receive that message. So that is also one of the drawback here in this sequence modification. That is, any modification to the sequence of messages between the parties, including insertion, deletion, and reordering. So uh, next one is time modification. So delay or replay of messages. See, if you are the message, we can read the suppose you have sent an audio or video message, which is in the time span of 2 minutes, just like that. It may be reduced to 1 minute, or it may be reduced to half minute, or it may be increased with unrelevant data, it may be increased to 5 to 8 minutes. Just like also they can modify the time. Just like that, we can say that it is a delay or replay of messages in a connection oriented application. An entire session for the sequence of messages could be a replay of some previous or valid session, or individual message in the sequence could be delayed or replayed. So in a connectionless application, an individual message, suppose if we are having some datagram, could be delayed or replayed. So then what we'll do, we can have, if it is some delay, then we have to wait up to the message should be delayed or not. Then what is a source repudiation? So denial of transmission of message by the source. Suppose it will take a 2 minutes time to send the message from the source to the destination, but the third party person who has entered in the middle of that, it may cause the corruption, like it may cause the deny of the transmission above by source. So these are the message authentication requirements. That is, we are having 8 message authentication requirements. Whenever you are going to authentic, why you have to give the authentication for the requirements means, if some other fraud alerts may cause, if you have provided this type of authentication, then the person who is going to receive that one will before receiving itself, he may be he will be in a secured position. Okay. Now let us see what are the message authentication functions. Here, any message authentication or the digital signature mechanism has two levels of functionality. So it is any whatever the message authentication or the digital signature mechanism, it is having two levels of functionality. First one is first one is at the lower level or the final higher level. It is having two levels. First one is lower level, and the next one is higher level. Okay. Next, at the lower level, there must be some sort of function that produces an authenticator. The person who is going to authenticate at the lower level itself, some sort of function provided. So this lower level function is then used as a primitive, and the higher level authentication protocol that enables a receiver to verify the authenticity of the message. So authentication functions that may be used for produce an authenticator. So these may be grouped into three classes. Again, these authentication functions are grouped into the three classes. See why you are going for this message authentication functions is before doing all those practice, if you have provided the authentication before itself, then the person who are going to receive the data will be in the safe side, such that he won't get that chance to what we say, mm, theft the data just like that. Okay, he doesn't having the chance to again and again, he won't get that chance. Okay, so here we are having the two levels. First one is lower level and next one is higher level. At the lower level itself, we are going to sort some function, and we are going to add some the authentication message, and this lower level function is then used as a primitive and the higher level authentication protocol that enables a receiver. It is going to enable a receiver to verify the authenticity of the message, and the authentication functions that may be used for the procedure and authenticator, these may be grouped into the three classes. Now let us see in how many classes it may be grouped. First one is message encryption, next one is message authentication code, we can write it as MAC. Next one is hash function. So what is a message encryption? We have already know what is a message encryption. We are going to change the normal text into the cipher text, we can say it as a message encryption. So the cipher text of the entire message serves it as authenticator. Okay, if we have converted the normal message into the cipher message, then it itself serves as authenticator. Okay, next function is message authentication code. Then how we will generate this message authentication code? It is a function of a message and a secret key that produces a pixel length value that serves as the authenticator. Okay, it is a pixel length value which is going to serve as the authenticator. Next one, hash function, the function that maps a message of any length into a fixed length hash value which serves as authenticator. So whatever the function that you have used, the function that maps a message at any length, whatever the length of the message, we have taken that length into a fixed length, then we can say it as a hash value, which is also serving as a authenticator. So now let us see how we are going to do the message encryption again. So this is how we are going to generate the message encryption. The message encryption by itself can provide a measure of the authentication. The analysis differ for the some symmetric and public key encryption schemes. So it may be different from the other symmetric cryptography or the public. We are having some encryption schemes, no public key encryption. Just whatever the encryption key we have applied, it doesn't matter, but it may be depends upon the symmetric or the public key encryption schemes. So if you have observed that it is a source and this is a destination, here this is a message that we are going to send. For this message we are going to perform the encryption, that is we are going to generate the key here. Okay, this is the MIM is encrypted some. So we have decrypted that message. Finally you will get the message to the source. From the source, what is the sender has sent that message, that will be received by the receiver. So we have already known, no, why you have applied for the just for the security, that how we, the third party person should not theft our data. Okay, next one, this is a message M. Then next one is if you have applied encryption here. Here we have applied public key encryption, confidentiality. For that we have, for this message we have applied the public key encryption, and for here we have decrypted, and this one is message. And next one, in this case, this is the public. Here we have provided the confidentiality, here we have provided the authentication and signature. See, for this encryption concept, we have applied the authentication and signature. After this is message, for that message we have applied the encryption technique, such that it is going to provide the authentication and signature. For that, after receiving that, it has to provide the decryption, and taking that authentication and signature, it is going to display the message for the receiver, that is for the destination. And next one, both if you we have now we have to seen that about the confidentiality and about the in authentication and the signature. Now let us see how we are going to apply for the these three: confidentiality, authentication and signature. Here we have applied these three in the last example. We have applied for these three. This is the message and we have applied the encryption technique here, and this is we have applied the confidentiality, authentication and signature we have applied here, and this one is the decryption that we have applied before going to encrypt the data. So this is the message that we are going to get. So these are the basic uses of the message encryption. Now let us see how we are going to generate this message authentication code. Basically a message authentication code is attached to a plain text. See, whatever the text we are sending, we can say that one as a plain text, no? So the message authentication code is attached to the plain text for the authentication check. So at the source side, the message authentication code is attached to the plain text message M, then transmitted to the destination. So at the destination side, the receiver has to calculate the MAC over the received message M. Then the calculated message authentication code is compared with the received message authentication code. So after calculation, we have to, first of all we have to calculate the plain text with the message authentication code, and it will be transmitted to the destination. At the destination side, the receiver has to calculate the message authentication code over the received message. Then it calculates the authenticated person. So if both these two has done, then automatically the receiver feels that the message is from the authentication person. Okay. So if you have observed this example, suppose this is a message authentication code. We can say this message authentication code is also cryptographic checksum, and it is a small block of data. It is having the fixed size. So it is generated by using the secret key. Whatever the secret key, that it is generated by using that secret key, and it is appended to the message. It is assumed that both the participants who are desired to communicate share a common secret by K. Then let the participants be A and B. If A wants to send the message to the B, then he calculates the message authentication code using the message and the key as follows. See, we can say this MAC as a message authentication code. So C is a message function, message authentication code function, and H is a secret key, and M is a input message. Okay. Suppose now let us see how we are going to calculate this message authentication code. The calculated message authentication code is appended to the message, and they are together transmitted to the recipient, and it generates a new message authentication code by recalculated it using the received message. Okay. Then the received message authentication code and calculated message authentication code are compared, which is shown as the figure 2.7.1. So the receiver will be sure that the message he received has not been subjected to the alterations, and as an opponent does not know what is the secret key that we have generated, and he can't able to alter that message, and he can know that, suppose if he had succeeded that altering message, then that receiver can find this whether in the both received or calculated message authentication code, and automatically it won't match each other. Okay. The receiver is sure that the message that he received is from the authenticated sender, because uh, by using the message authentication code to the message. So if the message received also contains a sequence number, then the receiver is sure that the attacker cannot alter the third person who has come into the picture. He has not altered any the message. So he can get that sequence number very successfully. Okay. So if you have observed this one, this is a source, this is a message that he had sent here. It is a MAC function, that is message authentication function that we have, that is we are generating the key here. After that we are going to share that secret key. So MAC is the message authentication code. So for this message we have sent the share secret key, and here we are going to at the destination we are going to compare the message with the original message. If it is matched with the sequence of the, if it has matched with the sequence of the numbers, then here, then the particular person, then the particular receiver will say that get the he can reach the he can reach that data immediately. So from this we can say that the destination B, so this is the message C of k comma m. From this we can compare that this is the step 1. What are the step? In the step 1 we will follow the message m and the message authentication code are arrived at the destination recipient. In the step 2 the recipient performs the same calculations on the received message using the same secret key, the MAC function, to generate the new message authentication code. And in the step 3 the recipient obtained the message authentication code from the received message. And in the step 4 the calculated message authentication code is compared with the received message authentication code. So from this we will get the conclusion, like, as only the recipient and the sender know their shared key, and if the received message authentication code matches, then the calculated message authentication code, then the message will be authenticated. Okay. So this is how we are going to provide the message authentication and confidentiality. For the authentication tied to the ciphertext, here this is a message from the source, and here this is how it is going to get at the destination. Here we are applying the just simply message authentication. Here we are going to apply message authentication with confidentiality and authentication tied at the plain text. At the plain text the authentication is paid here, and here in this message authentication and confidentiality, here we are going to provide the authentication tied to the ciphertext. So these are the basic uses of the message authentication code. So in the next class we will continue with the next topic.